All right, we're back. Here we go with number 4. Okay, so I need to find what I have to multiply to x squared to cancel out with 2x to the fourth. Sometimes it's hard for people to think about, so I like to do this. You kind of do this in your head. All right, if I were to divide 2x to the fourth by x squared, okay, what would I be left over with? Well, this would become 2, right? 4 minus 2 gives me 2. So I'm multiplying by 2. Should put it up. 2x squared. Okay, so I multiply each factor by 2x squared. So this becomes 2x to the fourth times x, so I get 2x to the third. All right. Change the signs. Minus, minus. These cancel out. This just becomes negative 2x to the third. Okay. So now I want to think about, all right, what am I going to have to multiply to? Holy buckets. What am I going to have to multiply? Negative 2x to the third to cancel out with x squared. All the way around. X squared to cancel out with negative 2x to the third. Okay, well, I'm going to multiply a negative 2x. Because when I multiply a negative 2x here, sorry, I forgot to bring this x to squared down. You got to bring that one down. If I multiply negative 2x here, I have negative 2x to the third minus 2x squared. But remember, what do we do every time? We change our signs. Okay, we change our signs. So these cancel. 5x squared. Bring down the 0x. What am I going to have to multiply to 5x squared? What am I going to multiply to x squared to cancel out with 5x squared? You guessed it, 5. A positive 5. Again, I could use this method as well. 5 times x squared gives me 5x squared. 5 times x gives me 5x. Change my signs. Oh my buckets. It's red, dude. Change my signs. These cancel out. I'm left over with a negative 5x. The minus 6 comes all the way down. I cannot multiply anything to x squared to get negative 5x. So this is my remainder. Did I change my... Hold on a second. My remainder is my answer is 2x squared minus 2x plus 5 plus my remainder all over x squared plus x. Okay? And we write that remainder, we write it, leave it just like this for our answer. All right? Let's go on to the next one. Okay, let's go to number 5. Okay, we want to put this in vertex form. It's going to be a lengthy process, remember. In order to have vertex form, I need to complete the square. So I need to divide everything by my 2. Okay, so I have f of x over 2 equals x squared minus 8x plus 15 over 2. To complete the square, I have to move this 15 to the other side. I'm going to leave a space here. So this is plus blank, plus blank. Okay. So, remember I need to take half of 8. Half of negative 8 is negative 4. Negative 4 squared is 16. 16. Okay. I want to rewrite this. Excuse me, my binomial squared. Half of negative 8 was negative 4, so it's x minus 4 squared. All right. 16 can be written as 32 over 2. All right, because 16 times 2 is 32. Like that. Okay. So I have f of x over 2. If I combine these, I get 17 over 2. All right. I want to move this 17 to the other side. And now I don't want this 2 on the bottom of in the denominator of my f of x, so I multiply it to everything. To everything. Everything. The 2 cancels out here. The 2 goes out in front of my parentheses, and the 2 cancels out there. So my vertex form is f of x equals 2 times x minus 4 squared minus 17. The vertex, remember the vertex comes from here and here. I take the opposite of the inside, so 4, and the outside stays the same, so negative 17. Okay, 4, negative 17. Don't use the 2. The 2 tells us how much I stretch or shrink the graph, all right, or whether it opens up or down. It does not affect my actual vertex. That was a common mistake on our last test. Okay. Next thing, I need to find my x-intercepts. So I'm going to set my vertex form equal to 0, or my original function equal to 0. I'll just use vertex form. It's going to be easiest. Add the 17. Divide by 2. Square root both sides. So I have root 17 over 2 plus or minus, and this is x minus 4. Add the 4 to the other side. X equals 4 plus or minus 17 over 2 square root square root. Now I cannot have a radical in my denominator, so I must rationalize. Times root 2 times root 2. So this becomes 4 plus or minus root 34 over 2. To write that as my x-intercepts, I would just do that and 0. Those would be my x-intercepts. Okay. For the y-intercept, I'm going to plug 0 into my original function here. Okay, if I plug 0 in for x, back into my original, I get 0 squared minus 16 times 0 plus 15. So my y-intercept is 0, 15. Okay. Last one, is isn't the x equals negative 2 a solution to the polynomial, and how do you know? So in order to determine if it's a solution to the polynomial, okay, I could do this 2 ways. I could use polynomial division, or long division, like we did in number 4 with the factor of x plus 2, or I could use synthetic division, which will go quicker, so I'm going to use synthetic division. Remember, I use my coefficients. 5, there is no x to the 4, so I must put a 0 as my placeholder. Negative 1, there is no x squared, so I need a 0 placeholder. 2, and negative 10. First number comes straight down. I do this number down here times what's in my box, so I get negative 10. Add straight down, negative 10. Negative 10 times negative 2 gives me positive 20. 20 plus negative 1 gives me 19. 19 times negative 2 gives me negative 38. Straight down, negative 38. Negative 38 times negative 2. Oh. Okay, negative 38 times negative 2. Sorry. Gives me negative 76. Negative 76 plus 2 gives me negative 74. Negative 74 times negative 2 gives me something really big. Sorry, 74 times 2 gives me 148. 148 plus negative 10 gives me 138. So, unfortunately, no, this is not a solution because there is a remainder of 138. Now, on the answer key, I believe it says 64. I just double checked that work, and obviously I got something else. We forgot to include this placeholder here for the 0. Apologize for that. You should have 138 as your remainder. Either way, you'll see that this is not a solution. Okay? So no matter what, you should still get no solution. All right? See you, bye.